Let me define you some concept to define this. Suppose you have spring attached to any support having this much amount of length. Let's say L in its natural state. Now, if you compress it, to this part, or if you extend it or stretch it to this part, from this actual position is termed as mean position. If you compress it or if you stretch it, due to this compression or expansion, a force will develop into it in opposite of its displacement. So it will be along this direction, and for this, it will be along this direction. This force is termed as restoring force, which having tendency to regain its original length or original shape. Is it clear till this part? Let's say there is a spring which having natural length as L. It means this position is mean position. So if you compress it or if you stretch it, a force get developed into this particular spring, which will tend to regain its original shape if you remove your deforming force. Then the tendency of this spring to regain its original shape on removal of deforming force is termed as elasticity. Is it clear?
Yes, sir.
So first we defined what do you mean by elasticity. Suppose you have solids in which molecules are arranged on the vertex of a cube. Let's say this particle, this particle. And the bond in between them behaves as spring-like structure like this. Now, if you apply a deforming force on it along any direction, let's say to deform this solid to this point. Now, due to the property of elastic nature or restoring nature, force will develop on it to regain its original shape or configuration. This property of solid, which is similar to spring-like behavior, is termed as elasticity. Nabila, is it clear?
Yes, sir.
So you'll say the tendency of body to regain its original shape on removal of deforming force is termed as elasticity, and opposite of this is plasticity. Means the inability of a body so that they can't regain its original shape on removal of deforming force. It will be termed as plasticity. So the next is the inability of body so that original configuration on removal of deforming force is termed as plasticity. In general, there is no any object which is perfectly elastic, or perfectly plastic. So the property of solid lies in between elastic and plastic. So you'll say property of body lies in between elastic and plastic. Is it clear to all of you? Akash?
Yes, sir.
Okay, just write it down to this part.
So that's why we call the material plastic, right? So that it because it does not reform its original shape again when we crush it or something.
Yes.
Done.
Sir, just a second. Done, sir.
Minashi, you have written?
Yes, sir.
Khalid?
Yes, sir.
Now, the first term in this is stress. Suppose there is a body or solid which is hanged by any support, and if you apply a deforming force on it, area of cross section in this part, let's say A. So stress is the amount of deforming force acting on the body per unit area is termed as stress. So the amount of deforming force acting on a body per unit area. So stress equals to deforming force divided by area of cross section. Unit of force is Newton and area meter square. So SI unit is Newton per meter square. Is it clear?
Yes, sir.
Now, due to this stress, there will be some elongation in this body, let's say to this part. Actual length of rod is L and deformation from this part to this part is delta L. So we may define another term related to this deformation as strain. So a strain is basically calculation of amount of deformation produced in this particular body with respect to its original shape. Or you'll say the ratio of deformed shape to the original shape of the body is termed as strain. So a strain is nothing but the amount of deformation produced in a body with respect to its original configuration. So strain equals to ratio of deformed shape to the original shape. As deformed shape and original shape but having same unit, so you'll get strain as unitless quantity. Is it clear?
Yes, sir.
Okay, just write it down to this part. You all have written?
Yes, sir.
Yes, sir, done, sir.
Khalid,
Yes, sir.
Minashi.
Yes, certain.
Okay, so let's stop here. In next class, I will define you rest of the part of this part. Let's so revise till this part. We'll continue next class.
Yes, sir.
Okay then.
Thank you, sir. Good night, sir.
Thank you. Salman, just wait for a few minutes.
Okay, sir.